finished system. Lots of choices. We're going to see lighting technologies out there, the fixture components, controls. There's a bunch of application-specific fixtures out there, and I encourage you to look at those when you're making decisions about, especially specific tasks, and working with real detailed, oriented stuff. I encourage you to look at the application-specific fixtures, and then always consider the life cycle of the product. Ballasts or drivers, sometimes they're known as. So ballasts, what are they for? They're for fluorescence, obviously. They're for all of your HID lighting, which is your metal halide and your high pressure sodium, low pressure sodium, and the mercury vapor that's gone away. But they're also used in LEDs. Drivers are not called ballasts, they're called drivers in LEDs. And so in the fluorescent, we started out with magnetic years ago. I think they started to phase in the electronic in the 80s sometime. And then they went through different scenarios from instant start to rapid start. Now there's a little bit of an improvement on rapid start over instant start, about a 5% change. But then there's program start, and there's significant changes there, not only with efficiency, but with the life of the ballast and the lamp. So right now our standard on campus is we're buying about a 27 watt, I think it's 27 watt T8 GE product, and we're marrying it with the GE ballast. I forgot what it's called, but anyway, the combination of the two gives us a 5-year warranty on that retrofit package, which is really powerful to us, and it's really something our maintenance staff likes to see. So it makes a big difference. Ballast factor, what we mean by that is how the ballast controls the current going to the lamp, and so that can be underdriven or overdriven based on the ballast factor. You can get a little bit more light out of a fixture or a little less by tweaking that, and in tune get energy savings out of that. Initial cost is important. I talked about the program start being great, but it also comes with a higher initial cost. But we think the life cycle cost is there when we look at the entire 5-year project. Multi-level switching versus dimming. At UCF, we're a real fan of the multi-level versus the dimming. We try to use it everywhere we can. The only time we use dimming is when we absolutely have to in an environment where we have a lot of this type of equipment, whatever it's called, audio-visual equipment, where we need to control it very specifically. Otherwise, we'll use the multi-level with the automated controls. And then communication. There's actually, these ballasts now communicate with each other and with central stations to do some load management in the facility. All that's available. We're not really pursuing that at the university. Task lighting. We talked about this a little bit, but this fixture's up here. There's that same fixture. It's up here 54 inches above the work surface. So because of this inverse square law that comes with all lighting, all kinds of radio frequencies and light frequencies, it takes 15 times more power for this fixture to put the same amount of light on this table as this task light does. So it's really dramatic. Savings can be realized. And I'm going to show you a little example of what I did in my office here later on using task lighting and how dramatic that is. But always keep in mind your uniformity. You want to, again, inside the office, it's a 3-to-1 recommendation from the IES. So you don't really want your ambient light, the spaces away from your task, to be below 3 times your task light. So keep that in mind. Here's just some examples of, obviously we want to stay away from the incandescents. I went to Office Depot website and found some of these things, but it's amazing how they're still selling these products, and how difficult it is to buy an LED product. But this is where LEDs really shine, is in this kind of market. And I guess they're starting to come out now. I don't know if they're still if they're available yet at the big box stores, but they're available online now. Lighting controls, we touched a little bit on this, but there's all kinds of Prethla available nowadays, from occupancy, dimming, local control versus centralized control. Light harvesting we hit on, site lighting, what to do out there, and I've got a project at the university I want to share with you on the site lighting control. But some of these are wireless technologies, some of these are wired. And I'm sure you have the salesmen and salespeople knocking your door down about this stuff, because I do, and there's a lot of new. So I encourage you to look at the product, but look at it with a grain of salt. Make sure that try to compute your life cycle cost on this kind of product and understand what's going to take to get it commissioned properly. It just doesn't install itself, and it needs to be configured properly to really get the numbers that the savings that they're predicting that you're going to get. So I encourage you to really look at it carefully. Occupancy sensing, here we've got two different technologies. The one on the left is the older, what's it called, infrared technology, and it follows these defined bands it's got these bands that come out from the emitter, and so the way that gets actuated is for an object to cross over one of those bands. So if this object is moving within the band or whatever, this sensor won't see it. It only sees it when it crosses these boundaries. And these boundaries get further apart as you get further away from the sensor or the emitter. So that was the original. The newer ones are radio frequency. This is a ultrasonic transducer, so it comes out in like a radio transmitter. And it will, not only does it kind of eliminate this problem with the banding, it also will go through some obstacles or whatever. It'll go around some obstacles. And you can also buy them dual technology, which we encourage you to look at, is because they both have advantages and disadvantages. So I'd encourage you, if you can afford, to look at the dual technology or the tri technology. At the university, we've had a lot of success with another technology that's not on here. It's an actual sonic sensor, and so it listens to the space, and we use them exclusively in restrooms. So if someone's in a stall, it will hear them in there, whatever, making any kind of noise, and it keeps the lights on for them where it doesn't need to, which you can imagine how critical that is. My old boss wouldn't ever let me put a sensor in the bathroom, whatever. He was just paranoid about being stuck in a stall. So he finally left, and we started installing them everywhere. Now we've got these sonic sensors everywhere, and I haven't heard any negative feedback at all from them. So they're working very well. So we also use those in classrooms and things. We use them in office spaces where we have partitions up that you might get hidden behind. Everyone's heard the horror stories where you have the false offs and ons and things like that associated with these sensors. So I encourage you to really look at all the different technologies out there before jumping on one. Daylight harvesting. This is a good example here from the university where we're bringing in natural light, and in this scenario here, you can see that the lighting level is perfectly acceptable, where these lights are now off. So this is what we mean by this is an automated system where we're sensing the natural light as it comes in, well, here I've got it right. The actual rising and falling of the sun follows this yellow light, and as that's happening, the automated sensor is either stepping back the amount of light or it's dimming. Again, at the university we use the stepped approach because it's much less expensive. It's tremendously less expensive. We can buy I don't know what, they're 4 times as expensive or something like that, the dimming system versus the stepped.
It's more noticeable to people.
That's right. That's right.
The lights came on. And
yeah, you're absolutely right. Yep.
The dimming, they don't even notice it at all.
That's right. You're right. Yeah, that's a big advantage with the dimming, absolutely. And then there's wired and wireless technologies here as well. So if you're looking at a retrofit application, you might want to look at the wireless. It might cause you some additional, savings in labor. They're very simple. The receiver can be mounted in the wall switch, and then the wireless can be mounted in the ceiling, and it just has a couple clips that can press right into a ceiling tile, and that's it. You're done, and it marries itself automatically to the receiver unit, and can begin working right away. Commissioning, again, I want to stress how important that is. I've touched on that, so I'm not going to belabor that, but I just think these systems don't work by themselves. They've got to be properly set up and properly operated and maintained. Load shed ballast is something we haven't used at the university yet, but I have some reservations about this whole method of reducing energy consumption. What we are doing here is either receiving a signal from the utility company or from the building operator to reduce consumption. So we're at we're obviously in a time of use type of situation or rate structure where we're trying to lower our energy consumption during a specific time of day. And so what this communicating ballast allows you to do is to send a signal and reduce either the levels of lighting, either by turning off every other fixture or dimming or stepped approach of some kind. So that has its place, but I'm concerned that it could have a negative impact on productivity, so we haven't gone there. This is that simple example I talked about in my office when I came to the university. They gave me a 100 square foot office that had 3 4-light fixtures in it. They'd already been retrofitted to T8s from T12s, but they still had 32 watt bulbs in them, which we don't use anymore. Now we're at 27, I think is what we're at. And so we were, I was using 300 watts when I'm in there, and so I work about 2,000 hours a year, so it's costing the university like $93. I think that's an incredible amount of wattage for a 100 square foot office. So I went and I got my light meter out and I measured the light levels, and I found out if I take out 3 of the 4 lights in each fixture, I end up with 1 lamp in each fixture. I've got just the right amount of light. I was sitting at like 40 or 45 foot candles or something like that on my desk. And so I've gone from $93 down to $16. Next thing I did is realize I'm not there all the time, put in an occupancy sensor, and this is an estimate, reduced it to, I'm out loafing about 8 hours, 4 hours a day or something like that on the campus. So only 4 hours in my office, and they get down to $8 for the year. And then finally, this is that light I was telling you about that I ordered off the internet. This is a LED task light, and it uses 5 watts, lights up my entire desk. And so when I have the opportunity, whatever, I can turn off the ambient light and use that. And I kind of ignore the IES recommendations, whatever, because I'm the only one in the space, whatever. I'm not worried about the uniformity as much. So I wanted to touch on LED a little bit. I know the salespeople are out there beating the bushes with this product as being the greatest thing ever, but I'm not. I think it has its place, but I'm not widespread implementing it right now at all. I think its strong points are over there on the what is that, left, and they're selling it in the big box stores now for decorative strings and for under cabinet. You know, they've got it in Home Depot and Lowe's now. But I think what's real specific about LED is that its advantage and disadvantage is that it's real focused, right? All the light comes out one side. Where these light bulbs we've got in here, it's every other kind of light bulb puts out light in a 360-degree span, where LED focuses it in one place. So that's where it really gains, even though it's not that efficient when you measure the actual lumen output per watt goes into it. If you're able to use that focused light in some task, like on my desk, I can light up a couple pieces of paper, then it's extremely efficient. So I encourage you to look at places where you can really focus it, but be careful with the the documentation that's put out of these things. Like, for instance, those efficacy numbers that I presented earlier, or whatever. The way they test these things is that what's called a junction temperature or whatever. That's the temperature inside the actual device in here, the silicon device. They measure it at like a 25 degrees Celsius junction temperature, and that's not realistic. I mean, that happens when they first light it for the first couple seconds. So they measure those and they publish those numbers, and it's true. And they always put a footnote that says 25 degrees C, and that's true. But what they don't tell you is they operate at some 75, 80 degrees C. And so take all those numbers and depreciate them by about 15, 20% to get to where you're really going to operate at. And that's just the lumen, out of the light bulb itself. And then there's the fixture. This happens to be a overhead recessed fixture that can be easily retrofitted to a existing can. And we have used a few of these and had some good success with them. I'm kind of skeptical of, not only the efficiency of them, but also the life of them. When they started to come to market, they talked about, well, we don't even need to talk about life because they have no end of life, whatever. They just go on forever. Then they started talking about, you heard that, right? Yeah. Then they started talking about so many hours and yeah, we bought some of them, right? And now they're not that much, they're not that much greater than a long life fluorescent. and induction lighting. I guess some induction lighting actually might surpass some LED lighting.